Hello everybody. Today we're going to do inverse of a cosine, just the cosine. But before we do inverse of specifically cosine, let's go back over the inverse of a function. Or just, is the function really a function? So in order to determine if your function is actually a function, you do the vertical line test. And so if you draw any vertical line anywhere on the graph, it's only allowed to touch that function one time. So like for example, this would pass the vertical line test. To determine if the inverse is a function, without actually calculating the inverse, without knowing the inverse, no equation, just from the picture, we would do the horizontal line test. So from the original graph, the horizontal line test would be if we draw any horizontal line, and if it crosses the graph more than once, then it's not an inverse. So this has no inverse. So again, let's just kind of go back through that again for problem number 2. Is this picture a function? And yes, it is, because it passes the vertical line test. Is the inverse a function? Again, we don't know what it is. And that, of course, is also yes, because it passes the horizontal line test. So let's specifically talk about the cosine. All right, we're going to start by drawing the graph because the graph clearly is helpful. So it says draw the graph of the cosine over the domain 0 to 2 pi. Typical domain, nothing special. It has an amplitude of 1, 2, 3, 4 slash marks. There's the 2 pi halfway. The cosine starts high and at its maximum as well, and halfway it's at its low point. And so here is the cosine graph, just a little piece of it. Is this graph a function? So that is your vertical line test. And yes, the graph is a function. So cosine is definitely a function. Is the inverse a function? Inverse is the horizontal line test. And no, the inverse is not a function. So when your inverse is not a function, you are forced to restrict the domain to make it a function. So if we think about, well, where could we cut this graph off so that it would pass the horizontal line test? Well, 0 seems to be a good place to start. So if we cut this graph off right at pi, just 0 to pi, then it would pass the horizontal line test, and that would make it allowed to be a function. So that's what we're looking for. So we're going to cut it off from 0 to pi. We're going to include 0, and then we're going to also include pi. Now, just in general, a little reminder of how do you actually find an inverse, because we're going to need this here in a minute. And that is, of course, you simply switch the x and y. Now remember, that applies everywhere. In an equation, x and y in terms of the actual points on the graph. It also includes switching the domain and range, because they are also a representation of x and y. So in order to write the inverse cosine, these are the two ways we have. Cosine to the -1, or another way is to use the word arc. So arc cosine would be inverse cosine. So if you think about the unit circle, the unit circle says, hey, here's an angle, let's say pi over 6. What's its cosine? So the question is the angle. So we're putting in the angle, and we're getting out adjacent over hypotenuse. Essentially, that's what it is. In the unit circle, you've memorized those values. Those are all shortcuts to special right triangles. 30, 60, and 45, all special right triangles, and we just learned them as angles rather than as triangles. So let's go back through some cosine. Don't forget about your unit circle values. That's what these are. So if we start with something easy, start with the beginning of our domain restriction. So we start with 0. The cosine of 0 is 1. If we put in pi over 2, so the cosine of pi over 2 is 0. If we put in pi, the cosine of pi is -1. So let's put these on the graph. And so it says to graph the inverse. So to graph the inverse, we have to switch the x and y. So we're really going to graph the point 1, 0, 0 pi over 2, and negative 1 pi. So we have the point 1, not quite over, all the way over, 1, 0, up pi over 2, and negative 1 pi. Can't really tell what our graph looks like, so let's throw in some easier ones. Let's throw in the cosine of pi over 3, which is 1/2. So I'm going to go over 1/2 and up to pi over 3. That might help us a little bit. And then, of course, negative pi over 3 is negative 1/2 because we're in the... Oh, and let's not do negative pi over 3. Let's do 2 pi over 3. Make it negative, right? I'm trying to get into the second quadrant. So then we would have negative 0.5 to the left and up to 2 pi over 3. And so this gives us a better idea as to what the graph looks like. It does not have arrows on it because remember we restricted the domain. So we're only allowed to go from 0 to pi. So that was the domain of the cosine. This is the domain of the cosine, and we graph the inverse. So it's not the domain of this graph. The domain of this graph, as you can see from left to right, is negative 1 to 1. The range now, though, that is our old domain, 0 to pi. It doesn't have any symmetry, meaning the y-axis, certainly not the y-axis, and certainly not the origin. If we spin that thing, it's not going to look the same. So we have no symmetry here. So at the top of this next page, I'm just kind of giving you a unit circle if that helps you sort of visualize where we are on the unit circle. If it doesn't help you, then don't use it. But remember, now we're kind of going backwards. Inverse is not reciprocal. Inverse is to read it the other way. So if we think about the cosine, if we think about where 0 to pi is on this unit circle, we're only using these values of cosine. Basically, you are forbidden to go into these other two quadrants. So you can't use angles like negative pi over 2. You cannot be in the third quadrant and call it 4 pi over 3. So we're not allowed to use those answers. So where is the cosine 1? This is asking you what angle has a cosine that's 1. So here's the point 1, 0. Here's the point negative 1, 0, 0, 1. So we're reading it backwards. We're basically reading it from the outside back in. So we're looking for where the cosine is 1, and that's right here. So we would say, okay, well, what angle is that? And it says to do this in degrees and radians. Well, 0 degrees is the same thing as 0 radians. The difference is 0 radians doesn't have a symbol. So what angle has a cosine of radical 3 over 2? Well, pi over 6 is radical 3 over 2, 1/2. So if it helps you to have it to look at, there's your cosine. So this is pi over 6, and in degrees, that's 30 degrees. What angle has a cosine that's negative? Now, for cosine is negative in the second quadrant. So we're going to give a second quadrant angle because we're only allowed in the first or second. So this is this section of where it's negative. So we want to make sure you give a second quadrant angle. So that's going to be 3 pi over 4. And in degrees, that's 135 degrees. Because remember, we're working from 180. So for 180, then we want to subtract or go up 45 degrees. Now, this is just another way of writing it. It wants to know what angle has a cosine that's negative 1. Well, that's, of course, pi. And pi is 180 degrees. We're allowed to use 0. We're allowed to use pi. Now, with a calculator, some things about this. I would suggest that you put your calculator, if you go to mode, you put your calculator in degrees. You're going to understand this a lot better. The radian isn't written with pi. The radian is written as a decimal, and you may or may not even know what that is. So put your angle into degrees, and then you just simply type it in, second, and then cosine, and it'll show up cosine to the negative 1, and then you type in the negative 0.85. We're going to go to, I guess, 2 decimal places. So this one is 148.21 degrees. Check your calculator, at least do it once, and make sure you're doing it right. And again, second, cosine, see what the angle is here. It should get 56.63 degrees. Now, when you type in the inverse cosine of 1.23, this says no solution. gives you an error, not possible, can't do it. And the reason is, remember your domain. Your domain from the front goes from -1 to 1. So 1.23 is outside of the domain. And this is the problem with using anything that's not in the first or second quadrant. You're not going to get an answer. Now, of course, not every angle we're going to have will be in the first or second quadrant, but we'll get to that later, how to deal with it when it's not in either the first or the second quadrant. Now, number 12 is just your typical problem that you had in geometry. We have a 15-foot guy wire supporting a tower. We're going to assume, just for the sake of argument, that the tower is perpendicular with the ground. All right, so we're going to assume we have a right angle. And here's the wire holding it up. It's attached to the stake in the ground, so here's our stake, and on the ground it's 11 feet from the base of the pole. What angle is the wire making with the level ground? So we're looking for an angle, and of course the wire itself is 15 feet. Well, this is hypotenuse, this is opposite, and this is adjacent. So luckily for us, we have adjacent and hypotenuse, so we know that it's cosine. So we're going to set this up. Cosine of what angle is equal to 11 over 15? You don't set it up any different. Cosine is always stuck to the angle. So when you go to type this in, you'll type it in the way we did for 9 and 10. You'll do second cosine and then 11 divided by 15. You don't need to make it a fraction. You can if you want to. But we'll go to two decimal places again. So 42.83 degrees. So again, the inverse cosine, if you're told to use the inverse cosine, or if you're given this, abbreviation for it, you are finding an angle measure. So that's why we can do it in degrees and in radians. Now you do have an assignment, and your homework assignment is on page 251, and we're going to do 14 through 17, all of those. Thanks for watching.